Okay, now let's look at number 50. First, we need to really carefully read this question because all the information is included in there. So first, when metal A is placed in a solution of the salt of metal B, so which is B minus, and the surface of the metal A changes color, so meaning that there is a reaction going on in, when you put these two together. So we conclude that with A plus B minus goes to A minus plus B, because that's a reaction. And so if you look at A here, A to A minus, it means it gained one electron. So A is the going through reduction here. And B, because the redox reaction, B is the oxidation reaction here. And keep reading. So when metal B is placed in an acid solution, gas bubbles form on the surface of the metal. Gas bubbles. Okay, that's the key word here in this sentence. So when B is placed in an acid, so let's just assume acid because there's always H plus in all acid. Let's just use the H plus. And B plus H plus, because it's bubbling, you can assume that is the B is going through oxidation. So that means it loses electron. It goes to B plus. And, well, in turn, because this is going through oxidation, B is going through oxidation, H is going to be reduced, turning into H2. So now we have to balance the equation, and 2H plus would make the equation balanced. But remember, there's 2H plus here, which means there's 2 plus on the left side, and there's only plus 1 on the right side. So we need to add electron here on the left side, but it wouldn't really matter because this question is not asking about us balancing the equations. So now we get B is also a oxidation here. And when metal A is placed in a solution of the salt of metal C, so A plus C minus, no changes observed. So this thing, the delta G is positive, meaning that it's not spontaneous. So, well, if it's not spontaneous, meaning that C plus A minus would be working because the delta G would be negative, and the equation would be spontaneous. So let's write that out. C minus plus A. So here C, well, because it's gain electron, this is the reduction here, and A is the oxidizing reaction. Okay, so now we have analyzed the question. Now let's look at question A. So for number question A, will metal C cause formation of H2 when placed in acid solution? Okay, so one thing that we need to know is metals, when they are put in acid, they always form H2. But I will explain the process here. So the acid, let's again assume that an acid is H plus, and a metal. Well, you know, like the property of the metal is that it's willingly to give off electrons, so it's very likely to become a oxidizing reaction. So let's assume this is the oxidizing reaction, and then since this is oxidized, the H is going to gain a electron going to H, but hydrogen always appear in pairs. It can't stand alone, so it becomes H2. So let's balance the equation, and metal plus. Well, this 2 plus, let's add another electron in there to balance the charges. Well, you see the H2 is formed here. And for part B of the question, rank the metals A, B, C in order of decreasing, reducing strength. Well, let's look back at the information that we concluded from the question. So when C and A are put together, C is the reducing, C is undergoing reduction, and A is going over oxidation. So meaning that C is greater than A in the reducing strength. Well, and when you put A and B together, A is the reducing, going through reduction, and B is going through oxidation. So that means A is better than B in reducing strength. So the answer to this question would just be C greater than A and A greater than B.